Hey everybody. Today we're doing a couple of derivative problems using the limit definition. Here's the problems we're going to do. The first one's a rational expression, and the second one's a radical. First, let's review the limit definition of the derivative. F prime of x is the limit as h goes to 0, f of x plus h minus f of x all over h. We interpret that to be the instantaneous rate of change of the function f of x at any particular x value. Graphically, it's the slope of the line tangent to the graph y equals f of x at that x value. Problem 1, f of x equals 5 over 1 minus 6x. We're going to use this limit definition, of course, and the way we're going to do it is by taking x plus h, plugging it in for f, plugging it in for x inside the definition of f, and then subtracting off f and dividing the whole thing by h. So there we go. Now, I'm not comfortable having fractions inside of fractions. It's very easy to make mistakes when we deal with compound fractions. So the first thing I'm going to do is to rewrite that. Instead of dividing by h, I'm going to multiply by the reciprocal 1 over h. Now I don't have any messy fractions inside of other fractions. Now, let's remember our goal with this limit. We'd like to be able to just plug in h equals 0, but we can't do that while we have an h as a factor in the denominator, as we've got here, as we've got in the limit definition of the derivative. So we're going to want to simplify what we have inside of that bracket until finally, hopefully, we can cancel the 1 over h that we have outside. So we're going to go about that by getting a common denominator of what's inside the bracket, like so. Here, I've cross-multiplied. 5 times 1 minus 6x minus 5 times 1 minus 6x minus 6h, all over the product of those two denominators. Next, I'm going to FOIL out in the numerator and combine like terms. I'm just left with 30 times h. Now I'm happy. Those h's cancel. And I'm in a situation where I can just substitute in h equals 0 to evaluate the limit. The denominator here will no longer be 0. Overall, I get that the derivative of 5 over 1 minus 6x is 30 over 1 minus 6x quantity squared. Problem 2. G of x equals the square root of 7x plus 4. Again, I'm going to want to use the limit definition of the derivative. Limit as h goes to 0, g of x plus h minus g of x all over h. Okay, so my goal is still the same. I want to get rid of that h in the denominator. Here, though, it's less obvious how we should proceed to simplify to be able to cancel that h. There's an important trick to keep in mind. It's multiplying by a conjugate. And what I mean by that is to take that subtraction problem in that original numerator, the one radical minus another, and then write it with a plus sign, so the sum of the radicals rather than the difference. I want to multiply the numerator by that. But I also don't want to change the problem in its ultimate value, so I have to also multiply the denominator by it. Here I'm just multiplying by a fancy name for 1. Why would I want to do such a thing? Well, the numerator is now of the form a minus b times a plus b, a difference times a sum of the same two things. And so that's the formula for the difference of squares. A minus b times a plus b is a squared minus b squared. So the numerator is the square of the first radical, so 7 times x plus h plus 4, minus the square of the second radical, so 7x plus 4. And now that numerator is going to simplify. The denominator I have not simplified in any way. I've just left it in the form h times the sum of those radicals. Again, remember my goal is to cancel that h in the denominator, so I like it as a factor. Foiling it out will not help me here. Okay, let's simplify the numerator by combining like terms. I'm just left with 7h. And now those h's cancel. I'm left with 7 over square root 7 times x plus h plus 4, plus the square root of 7x plus 4. And now I can evaluate my limit by plugging in h equals 0. My final answer is 7 over 2 times the square root of 7x plus 4.